The term square root has its genesis or origin literally from a geometric square. A square is a four-sided, two-dimensional shape with four right angles and four sides of equal measure. If we know that the area of a square is derived from the formula area equals length times width, a square with side lengths of x units will have an area of x times x, or x squared. For example, a square with side lengths of 1 unit will have an area of 1 unit times 1 unit, or 1 unit squared. A square with side lengths of 2 units will have an area of 2 units times 2 units, or 4 units squared. A square with side lengths of 3 units will have an area of 3 units times 3 units, or 9 units squared. Conversely, if we are given the area of a square, we can determine its side lengths by determining what number squared would equal its area. This is referred to as taking the square root of a number. So, given a square with an area of 16 units squared, we can find its side lengths by taking the square root of 16 units squared, which will give us an answer of 4 units for the side lengths. Notice that in all of these examples, we had side lengths and areas that were positive integers. This is why a positive integer whose square root yields another positive integer is referred to as a perfect square. Now, let's look at what happens when we draw a tilted square within our 2 by 2 square. Notice that although this square is tilted, it still has 4 right angles and 4 sides of the same measure. Remember that the area of a square with side lengths of 2 had an area of 4 units squared. Can you see that the tilted square is composed of exactly half the area of each of the unit squares? As a result, the area of the tilted square must be half the area of our original square, or 2 units squared. Since we've already found that by taking the square root of a square's area, we can find its side lengths, we know that the side lengths of the inscribed square will equal square root of 2 units. We have already found that the square root of 1 is 1, and the square root of 4 is 2. So the square root of 2 must fall between 1 and 2, and is therefore not an integer, but a decimal. If we were to investigate further, we would find that the square root of 2 yields a decimal that doesn't terminate or repeat, and therefore it cannot be expressed as the ratio of 2 integers. In other words, it yields an irrational number. There are many more irrational numbers that lie between any 2 rational numbers on a number line. In fact, the square root of any number that is not a perfect square will always yield an irrational number.